Thanks again to the organizers of this colloquium for inviting me to speak on a topic that is very dear to me, even though, as you know, I have not done much work on the 15th and 16th centuries. My presentation will therefore be that of a medievalist, and I shall endeavor to provide some background information on the period covered by this conference. The title chosen for this meeting, Isomorphism in Two Pieces, indicates a research direction, so to speak. The distinction between matter and form was progressively called into question until it disappeared under the fateful effect of the new physics in the 17th century, as recalled by Sylvain. As for the subtitle, it suggests that reflections on the notions of atom, minima, and elements would have played a crucial role in this process of transformation of Aristotelian science. In other words, you invite me to raise the following question: was the concept of atom already in the Middle Ages an alternative to substance and thus to matter-form couple? I might as well say straight away that I don't think so, at least for the period I know, 13th and 14th century. Or only partially in a very few rare cases. The one who goes furthest in this direction is undoubtedly Nicholas of Autrecourt in the 14th century, in his treatise entitled Exegit Ordo, which contains a radical critique of Aristotle. Is the only one who clearly states that the atomistic hypothesis is at least as probable, if not more probable, than Aristotle's substantialist hypothesis. Is the only one, moreover, to propose to reduce the various changes in Aristotelian physics to local motions of atoms. However, he continues to speak of matter and form, and there is at most a kind of transfer of subject from substance to atoms, since on several occasions he suggests that atoms are the subjects of forms. I will come back to this later. The other philosophers or theologians who are classified as atomists also maintain the general framework of Aristotelianism, and in particular isomorphism, since atomism is most often used to describe the structure of matter and of matter only. What then are they trying to show or describe by asserting that any continuous magnitude or quantity is composed of indivisibles? In an attempt to clarify this issue, I would like to start this presentation by recalling some silent results of recent research. First of all, apart from Nicholas of Autrecourt, no atomists, as far as I know, between the 12th and the 15th centuries, accept the existence of an interstitial vacuum between atoms. Thus, they do not propose a description of the world as something discrete, as if our experience of the continuity of the material world were merely an illusion similar to that provided by the cinema, for instance. On the contrary, the world and the bodies that compose it are indeed continuous, even if their ultimate parts are indivisible. As in Aristotle, then, matter is continuous, and the distinction between beings is essentially made by means of forms, without which we would have only a formless and indistinct matter. But the question is, which form should be used to distinguish beings? That is to say, substantial forms, qualities, or also quantities. And if quantity can be used to distinguish beings, discrete quantity must be used to count these things. A fundamental question for atomists is therefore how to count the parts of matter that make up any continuous substance. Shall we use substantial forms, qualities, or only quantity and discrete quantity, by the way? Importantly, among the best-known atomists, from Robert Grosseteste to Henry of Arklay or Geraldus Adonis, for instance, indivisibles are most often described as points, puncta, that is, as geometrical points, and sometimes more vaguely as indivisibles, indivisibilia. When dealing with the question of continuity, the atomists first evoked the geometrical continuum, the line, the surface, and the solid, and their aim is to give credence to a thesis attributed to Plato by Aristotle, according to which solids are composed of surfaces, surfaces of lines, and lines of points. This thesis is therefore opposed to the idea that every body is composed of smaller bodies, according to a principle of homogeneity between the whole and its parts. This is where the difficulties begin, for one sometimes has the impression that these atomists intend to move from the mathematical description of three-dimensional geometrical solids to a description of natural bodies.
Aurélien,
yes.
I'm sorry to interrupt. I don't know if this is normal or not, but apparently we only see the first slide of your presentation. Is this
yes.
normal? Okay, so sorry about that.
It is normal.
Yeah.
So, yes, I was saying that one has the impression that these atomists intend to move from the mathematical description of three-dimensional geometrical solids to a description of natural bodies, as if the two should necessarily have the same structure. So are they defending a form of naive mathematical realism, but based on, let's say, a non-Euclidean geometry? Is it simply a tool to describe abstractly the structure of natural bodies? In either case, they need a theory of the relationship between the mathematical continuum and the physical continuum. And unfortunately, atomists do not always take care to accompany their theory with a meta-discourse on their epistemology of mathematics. As I've tried to show in several recent works, and I'm sorry to mention some of my papers, but for those who don't know them, these are the references. So in these recent works, I've tried to show that this particular form of geometrical atomism, which emerged very early in the Middle Ages, must be linked, as recalled by Sylvain, to the Neo-Pythagorean and to some extent Platonic tradition. According to this theory, points are indeed defined as units having a position in space, and geometric atomism is thus made possible by a form of subordination of geometry to arithmetic. As several historians of mathematics have noted for more than a century, notably Paul Tannery in France at the end of the 19th century, and more recently, Francis Cornford, this idea of the point as a unit having a position in space is typical of Greek, Pythagorean, and Neo-Pythagorean thought, as we find traces in the Greek Neo-Pythagorean mathematician Nicomachus of Gerasa, or in Jamblichus, for instance, and many others. In the Latin world, the main source of knowledge of this point unit atomism is Boethius' Institutio Arithmetica, which is a simple Latin translation of Nicomachus of Gerasa's arithmetic. In this text, Boethius attempts to explain the Platonic idea according to which the world was created from mathematical archetypes in the divine mind, but to go beyond Plato's presentation in the Timaeus, which stopped at geometrical figures. He goes all the way to numbers in the manner of the Pythagoreans. To do this, Nicomachus and Boethius try to show that numbers are somehow inscribed in geometric figures. There are units in each dimension, in the line, the surface, and the solid, and there is a kind of absolute unit, a primary monad, which would be the point, equivalent to the absolute unit in space, from which all geometric figures derive. This is why Boethius, following Nicomachus, asserts that the point is nothing but what the Greeks call atom, atomon in Greek. The whole book thus justifies this thesis, according to which any body, that is, any three-dimensional solid, is composed of surfaces, surfaces of lines, and lines of points, and by transitivity, any body would therefore be composed of points. But since Anneliese Meyer and John Murdoch, most historians of atomism have tended to limit their analysis to the atomists of the late 13th and early 14th centuries. This had led them to hypothesize that medieval atomism was born out of a reaction to Aristotle especially to his physics and his De Generatione et Corruptione. For this reason, they failed to grasp the importance of this Neo-Pythagorean model that I have just described, and which, in my opinion, structured the medieval debate on the continuum in depth until at least the 15th century. In an as yet unpublished article, I have attempted to show that as early as the 12th century, there are defenders of point unit atomism without any reference to Aristotle's physics and De Generatione et Corruptione. This is the case of William of Champeau or Peter Abelard, for instance. It is there in their rereading of Aristotle's categories with the glasses of Boethian arithmetic that we see the birth of the matrix of medieval atomism, which therefore pre-existed the arrival of the entire Aristotelian corpus and its Arabic commentators. But in the 13th century, once Aristotle's argument against atomism were known, some theologians and philosophers continued to use this first matrix, such as Robert Grosseteste, for instance. Following the Neo-Pythagorean interpretation of Plato's Timaeus, thanks to Boethius, he rationally explained the creation of the world in mathematical terms. According to Grosseteste, the world, or at least its matter, would be the effect of an infinite multiplication of a point of light, a description that he tries to make compatible with Greco-Arabic Aristotelianism. The explanation of the creation of the world through the infinite multiplication of a point of light allowed him to explain at the same time creation ex nihilo, the point being like a nothing in the field of magnitude, while preserving the Platonic doctrine of matter, the cora of the Timaeus, and the Neo-Pythagorean analysis of the numbers inscribed in geometrical figures, as in Boethius. Since the world was created in this way, by multiplication of a point, if we divide the magnitudes resulting from this multiplication, we should find the original points, which were at the beginning of the creation of the material world. Grosseteste is careful to describe this multiplication, and not motion, I insist, as infinite to counter the arguments of Aristotle's physics and other mathematical arguments assuming division at infinity. And as he himself suggests in his notes on the physics, which is the first commentary on Aristotle's physics, this worldview is in the tradition of Pythagoras and Plato, but also in the Augustinian tradition. In this theory, mathematical atomism only describes the creation and structure of matter, since the multiplication of the point of light generates the first matter, prime matter, immediately accompanied by its first form, which is the forma corporitatis, a concept he borrows this time from Avicenna. Initially, matter is only a body, that is to say, a large three-dimensional solid composed of points. And once this matter is created, it can then receive other forms, those of the elements, substantial and accidental forms, etc. In short, it is clear that this atomism does not fundamentally challenge Aristotelian hylomorphism and even the principles of Aristotelian physics. At the same time, from Roger Bacon, at least, this Neo-Pythagorean matrix was strongly criticized, thanks to logical and mathematical arguments transmitted by different texts, such as Pseudo-Aristotle's De Lineis Insecabilibus or Al-Ghazali's Metaphysica, which summarizes Avicenna's arguments. These arguments, especially those based on the irrationality of the ratio between the sides of certain figures, and other arguments called by projection, added to the intrinsic strength of the Aristotelian system. And they should have made the atomist bend, but this was not the case. On the contrary, I have the impression that almost all atomists between the 12th and the 14th centuries, at least, tried instead to accommodate as much as possible the Neo-Pythagorean matrix of their atomism with the general framework provided by Aristotelianism, either by accepting the obvious contradiction with Euclidean geometry, or by trying to distinguish between two approaches to geometry, one suitable for abstract entities only, the other for natural bodies. I believe I have identified at least one fundamental idea that is found in several of these medieval atomists. For them, it was first of all a question of preserving the continuity of the world while making this world countable. To do this, they propose not to oppose discrete and continuous quantities, that is to say, arithmetic and geometry, into radical manner. If matter is a continuous quantity, it can nevertheless be described by numbers which are based on an absolute unit, in this case the point, a unit with a position in space, even if for others there are units in each dimension, indivisible lines, for instance, etc. For some of these atomists, who could be called finitists, the point was to defend the finitude of the created world by asserting that the number of points in a continuous quantity is always finite, so as to reserve infinity for God alone. The fact that everything consists of a certain number of points, conceived as units in space, would thus make the world countable. For the infinitists, who consider that there is an infinite number of points in the continuum, like Robert Grosseteste in the 13th century or Henry of Arklay in the 14th century, the world will never be countable for us, but it is always countable for God. I will not go back over this problem, but I have the impression that by infinite, we must therefore understand indefinite for some of these infinitists, notably Robert Grosseteste. To this opposition between finitists and infinitists was added another opposition concerning the nature of indivisibles that are found in the continuum. Are the ultimate parts of geometric solids and natural bodies the same? Are they points or corpuscles? This is how Thomas Baldwardine summarized the 14th century debate in a famous and often quoted text. And let me quote it again to make sure that we all have this in mind. So I read the text. Concerning the composition of the continuum, there are 5 famous opinions among ancient and modern philosophers. Some of them, such as Aristotle, Averroes, and many contemporaries, affirm that the continuum is not composed of atoms, but of endlessly divisible parts. Others affirm that it is composed of indivisibles, and this in 2 ways, since Democritus affirms that the continuum is composed of indivisible bodies, while others affirm that it is composed of points. And this in 2 ways, because Pythagoras, the father of this sect, as well as Plato and the contemporary Walter Chatton, affirm that it is composed of a finite number of indivisibles, others of an infinite number. And these are divided in 2 groups, since some of them, like the contemporary Henry of Arklay, affirm that it is composed of an infinite number of indivisibles joined without intermediaries, while others, like Robert Grosseteste, that it is composed of an infinite number of indivisibles with intermediaries between them. So the division seems very clear. On the one hand, Democritian atomism, supported by Nicolaus Bonetus in the 14th century, for instance. On the other hand, Neo-Pythagorean atomism and its variants, finite number of points for Chatton, Crathorne, Odonis, and many others, or infinite without intermediaries in Arklay with intermediaries in Grosseteste. But Thomas Baldwardine does not say whether these answers apply only to mathematical continuum or also to natural bodies. Moreover, this table does not mention all the forms of atomism present at the time, and in particular, those that seek to bridge the gap between mathematics and physics. To the theoretical options identified by Baldwardine, we should add that of Nicolas of Vaudricourt, who, in my opinion, accepts both atomic bodies like Democritus and points like the Neo-Pythagoreans. We should also add another theoretical option, less known, which consists in accepting the existence of natural points. That is to say, a physical equivalent of geometrical points in natural bodies. In 2009, I wondered what William Crathorne meant by the expression point of gold or point of lead. As a tentative conclusion, I suggested as a hypothesis that since these points are forms, they could be equivalent to Aristotle's Minima naturalia. Yet such an equivalence is by no means self-evident, since Aristotle's Minima naturalia are still bodies, not points, and they are composed of matter and form, whereas points are absolutely, or are supposed to be absolutely indivisible and formless mathematical entities. This idea still intrigues me today. What could a natural point be? The very concept sounds like an oxymoron. Yet it is an expression that is also found in Ramon Llull, for instance, and later in John Wycliffe and his followers at Oxford in the late 14th and early 15th centuries. More surprisingly, this distinction between mathematical and natural points was still being discussed in the 16th century, as can be seen in the famous Tabula di Solidationum Indictis Aristotelis et Averroes by Marc Antonio Zimara, published in 1537. This Aristotelian philosopher, trained in Padua by Agostino Nifo and Pietro Pomponazzi, wrote the following in the entry Mathematicus of this table, and let me read the text. Although Aristotle stated in the second book of the Physics that physical bodies have surfaces, length, and points like mathematical entities, however, the natural philosopher does not consider these things as a natural philosopher, since they are separated and treated separately. But when he considers length without depth, he uses mathematical abstraction, as in many other cases, as Alexander Phaphrodisias has well noted. This is why there are no magnitudes other than the body, as Simplicius well noted, under the authority of Alexander in the first book of the De Cello. Therefore, natural lines are bodies, as are surfaces, and natural points are also bodies, inasmuch as they are natural things, like the minima naturalia, and like the poles of the world, which are natural things. But mathematical points are indivisible, as Averroes notes in the second book of the De Cello, commentary 14, and in book 4 of the Physics, commentary 118. And this is how the Peripatetics speak of these things, and this is the important part of the quotation. Note this carefully, for it is the greatest dispute among all Latins. Zimara's point is not absolutely clear. Like Aristotle, he is opposed to a strict mathematical realism that would admit the existence of mathematical entities in rebus as the ontological constituents of all reality. He thus opposes the Neo-Pythagorean mathematical ontology I mentioned earlier. But Zimara also seems to distinguish between two uses of mathematical abstraction. In the first case, one uses mathematical abstraction to think of one aspect of the thing separated from the others, its length, for instance, that is, separating one aspect of the body, length, width, or depth, for instance, although these things never exist in a separate state. Thus, one can think of a point in a natural body, but it does not correspond to anything in nature. In the second case, the mathematical abstraction seems to be used in a purely analogical way. We talk about points, lines, surfaces in natural bodies, but in reality, we are always talking about bodies. The so-called natural point is therefore not a real point, but the minimum of a body in 3 dimensions. In this case, if the mathematical abstraction corresponds to something in reality, it is not a strict correspondent, but something like an analogon of the point in the thing. Still in the 16th century, this maxima altercatio among the Latins was thus about the connection between the indivisibilist answer to the question of the mathematical continuum and the possibility of a form of physical atomism. I do not pretend today to provide a definitive insight into this question. I would just like to offer some clarifications concerning the different strategies used to bridge this gap between the mathematical question of the continuum and the ontological constitution of real and material objects. To do so, I will start with some remarks concerning the philosophical vocabulary of medieval atomism. Then I will return to the atomism of Nicolas of Fautricourt, which seems to me to provide the most coherent theory of these relations between atoms, minima, and points. I will end this brief presentation with the strategy of the defenders of the puncta naturalia, which seems to me far less clear than Fautricourt and other options. So first of all, go back in time. In his etymologies, written at the turn of the 6th and 7th centuries, Isidore of Seville defines the atom as follows, and I think it's important to read this text. Atoms are what the philosophers call corporeal particles in the world that are so tiny that they are not visible to sight and do not undergo tomen, that is splitting, whence they are called atomoi. They are said to fly through the void of the entire world in unceasing motion and to be carried here and there like the finest dust motes that may be seen pouring in through the window in the sun's rays. Some pagan philosophers have thought that all trees and plants and fruits are their origins from these particles, and that from them fire and water and the universe were born and exist. There are atoms in bodies, in time and in number. In a body, such as a stone, you may divide it into parts and the parts into grains, like sand, then divide the grains of sand themselves into the finest dust, until if you can, you will reach a certain minute particle, which no longer can be divided or split. This particle is the atom in bodies. You will probably have recognized behind this description a reference to the Democritean theory, taken up in part by Epicurus and especially by Lucretius, who also uses this image of grains of dust in light through the window. But further on, Isidore adds that the unit in numbers can also be called atom as well as points in geometric quantities. I won't read the text. This addition is in line with what Boethius says in the Institutio Arithmetica, and in a way reinforces the ambiguity or even the duality of the concept of atom, unbreakable body for the philosophers, point unit for the mathematicians. In the 13th century, some authors, such as Alexander Neckham, for instance, preferred to use the term atoms for corpuscles only. Others preferred to use the term atom for geometric points, from Grosset onwards, puncta or indivisibilia rather than atoma. But in general, from the 13th century onwards, the term atomus became more often synonymous with corpuscles. Whereas before, until the 12th century, it was a more generic term that can cover many different kinds of indivisibles. As I have said, while point unit atomism seems to be in the majority among the atomists between the 12th and the 15th centuries, there are also traces of the assimilation of Democritus' atoms to Aristotle's Minima naturalia. Roger Bacon, for example, in his Opus Tertium, mentions followers of Democritus, Democritei, without saying whether they are ancient or contemporary. But the context suggests that they still exist. Who are these followers of Democritus? We know of one in the 14th century in the person of Nicolaus Bonetus. Apart from perhaps Nicholas of Fautricourt, I have not found any genuine advocates of this form of corpuscularism, but traces of it can be found in some authors who justify the use of the term atom to refer to the minima of Aristotle. A very clear example of the reduction of atoms to minima naturalia is found in Albert the Great's commentary on the De Generatione et Corruptione. So I don't read the text, it is quite long, but you see at the end that it clearly states that this is what Democritus called an atom. He is referring here to minima naturalia in the precise meaning of Aristotle. The Democritian atom would not be the smallest body in itself, but the smallest body composed of matter and form. A minimal body which, if divided, would lose its form, that is to say, its nature, its identity. In other authors, we find a more refined vision of the relationship between atoms and minima. This is the case in a number of anonymous commentaries on Aristotle's De Anima, written in the years 1250, 1270. All these commentators defend the same thesis, namely that there are atoms, and that they should be distinguished from minima naturalia on the one hand and from points on the other. But the most detailed of them is the one preserved in a single manuscript in Siena and edited by Paola Bernardini in 2009. The context is the following. In Book 1 of the De Anima, Aristotle describes the position of Democritus, according to which the soul is composed of atoms, that is, of indivisible bodies and figures in infinite number. The atoms that make up the soul are spherical and have the nature of fire, which make them capable of moving the rest of the body. But the text goes on to say that these atoms are like the suspended dust in the air and the one that we see in the light through the window. And so here are the questions these commentators ask. So you see you have many questions, especially in the last one. And you have also other questions on the nature of the points later in the text, in the Bernardini, the Anonymous of Bernardini. To the question of whether an atom is a body, the four commentators answer that it is the case, since it has three dimensions. But is it a natural body? A body informed by a form that gives it a specific nature and operation? To answer this question, they distinguish between a natural body according to form or species on the one hand, and a natural body according to matter on the other hand. So sorry, I don't have, okay, so yes, I have English translation, sorry. In the first case, the atom would correspond to the natural minimum defined by Aristotle in the De Generatione et Corruptione, namely a minimum defined by the operation of its form. However, according to these commentators, there would be a body smaller than this minimum, but which would not have this capacity to operate through a form. And this is what is called natural body according to matter only. For the anonymous Bernardini, what is called an atom is therefore not so much or not only the natural minimum, it is first of all a minimal natural body according to matter only. More precisely, the atom would be a particle of earth reduced to inert dust by the action of the sun's heat. These tiny pieces of matter, although they may have the appearance of matter informed by the form of the element earth, are like the end of the paralytic. The figure is there, not the essential form that makes its operation possible. The example of the end of the paralytic comes from Aristotle's Meteorologica at the very end of Book 4, where he says that the corpse and the end of the paralytic are bodies or parts of human bodies by homonymy only. Although they do not really justify this assertion, it would seem that for them, there are only earth atoms, not water, air, or fire. Indeed, in answer to question 21c, the anonymous Bernardini replies that the atom is not a mixed body, but a simple body which has the nature of the earth. And I think, yes, you have the quote here. The reason given for this is a passage in De Generatione et Corruptione, where Aristotle says that without water, the earth no longer has its power of cohesion. This is why, by exhalation due to heat, it turns into dust, which is earth only by homonymy. It loses one of its main properties, namely what we should call gravity, which draws it towards its natural place, the center of the earth. This is what we see when we see dust atoms flying in the ray of light. And this is how we should understand this example, which is found even in Lucretius, and which is still quoted by Isidore of Seville. The atom is thus clearly considered as a body, indivisible in act, which may be smaller than the minima naturalia, but which remains divisible in potency, since it is a continuous quantity, as the anonymous Gill reminds us. As for the points, the anonymous Bernardini clearly states that they can be imagined by thinking of a unit in space as a point of matter contained in a situs indivisibilis. This anonymous commentator even defends a position that is very reminiscent of the Neo-Pythagorean position I described earlier. So there can be points in the continuum, but the parts of bodies are atomic bodies. There are therefore three kinds of indivisibles: points, atoms, and minima naturalia. We can think of points in natural things, but there is no such thing as a natural point. I now turn to Nicholas of Foucault, the most radical and consistent atomist in the Middle Ages. It seems to me that his atomism has been misunderstood because the distinctions I have just outlined have been overlooked. Indeed, in the first chapter of the Exegete Ordo, devoted to the eternity of the world, he clearly defends Democritus' thesis that generation and corruption are nothing but the association or dissociation of atomic bodies, and is referring to corpora atomalia. Let me quote the text. Thus, in natural things, there is nothing but local motion. And when from such motion follows the coming together of natural bodies, which assemble with each other and receive the nature of a subject, it is called generation. When they separate, it is called corruption. And when by local motion, atomic bodies join with the subject and are such that their coming together is produced neither by a motion of the subject nor by what is called its natural operation, it is called alteration. So every substance is therefore in reality a sum of corporeal atoms, of which one, or perhaps several, plays the role of the subject. So there are essential atoms and accidental atoms. Let me quote this second text. According to what has been said before, it will be said that such accidents are nothing but atomic bodies, and that they are in the subject only as a part in the whole. On the other hand, it is understood that there are essential and necessary parts to the whole, and they may be said to be more part of the substance of the subject. And these are atoms whose departure makes that what is called operation no longer appear, nor the movement that appeared before in the thing. The others are such that if they disappear, the motion and operation do not disappear. They are rather called accidents of the subject. They are nevertheless like parts in the whole. A body is thus a whole composed of atoms, some of which are essential to the operation of the form proper to a species of substance. The others are accidents and do not affect the specific identity of the whole. According to Christophe Grélard, Nicolas of Foucault would therefore accept atoms with certain qualities. It is true that he states that there are atoms of different nature, without specifying what these natures are. Foucault would thus move away from Democritus toward the theory of minima naturalia, applying the theory of minima not only to substantial forms, but also to accidental forms. At the same time, when he admits the idea that below a certain number of atoms, the form disappears from the subject, he seems to admit that some of the atoms that leave the subject do not take the form with them. Perhaps he therefore considers that there are also atoms smaller than the minima naturalia without active form, let's say, like the anonymous commentators of the De Anima. This is not very clear, actually. The chapter 2 of the Exegete Ordo is devoted to indivisibles, the next to vacuum, the next to the relationship between substance and quantity, and finally, there is a chapter on motion. These chapters form a whole, with the first one on the eternity of the world, and only deepen certain aspects of his atomism. However, the chapter on the indivisibles cannot be considered as a pure and simple defense of the atomism he defends in the first part. First, he no longer speaks of atoms or atomic bodies. Now he speaks of points and indivisibles. Secondly, he defends the idea that the continuum is composed of indivisibles, whereas in the following chapter, he will accept the existence of void between the atoms. So some bodies are continuous for Foucault, from atoms to certain larger bodies composed of these atoms without any void between them, although in nature there is a vacuum between some atoms or compounds so that their movement is possible. These atoms, like all continua, are composed of indivisibles, that is, point-like entities. Concerning the continuum, his criticism of Aristotle is very similar to that of Walter Chatton, Crowthorne, Arclay, Odonis, etc. Like them, he responds to the contact arguments of physics 6 with the notion of situalitas of the points in the continuum. each point has its position in space, and a line corresponds of the set to the set of this position. So exactly like the Neo-Pythagorean tradition. He responds to the argument of infinite division by asserting that this division would give rise to the existence of an actual infinite, and not only to potential infinite, and perhaps even an extended infinite, since the points occupy distinct positions in space. What is interesting is the conclusion he draws from these arguments. Let me quote this text. If then what has been asserted in the preceding solutions is true, two conclusions may be drawn concerning the problem of the composition of a continuum. Namely, one, a continuum is not composed of entities that are always divisible, and in this we will depart from the common opinion. Secondly, two, a continuum that can be shown to the senses or imagination is not composed of a finite number of points, and in this we would depart from the opinion of all those who have held that the continuum is composed of indivisibles. And according to these conclusions, the following propositions are true. 3, for any magnitude given or shown to the senses or imagination, a smaller one can be given. At least nothing seems to prevent this. And yet, it will be true at the same time that 4, in a thing, there is a magnitude for which no smaller one can be given. So since the works of Zénon Kaluja and Christophe Grelard, conclusion 2 has been interpreted as an endorsement of the infinitism of Grosseteste or Arclay. The continuum would be composed of an infinite number of points. It has even been seen as one of the first defenses of infinitesimals before Leibniz. But for at least 3 reasons, this reading seems to me to be wrong. First, Autrecourt speaks only of the sensible or imaginable continuum, thus known with and through a form, not of the continuum in general. Secondly, the negation may also concern the idea of points, so that he may have wanted to assert that the sensible continuum is not composed of points, but of other things, and in this case, I think of corpuscles in a finite number. Finally, since he says that he opposes all other indivisibilists, and that he knew Arclay's infinitist positions, according to Jean Célérette, I would be rather inclined to think that he maintains that the sensible continuum is composed of a finite number of corpuscles, of atomic bodies, which would be consistent with an analysis of changes or movements, but also with his arguments against Aristotle about infinite division. The sum of these atoms would not form an actual infinite, but a finite sum of finite, very small bodies. Moreover, just after this passage, he makes it clear that an indivisible alone, in this case is talking about the point, never presents itself to the senses or the imagination as a being with a form, as an ens formatum. In other words, even if there are points in the sensible or imagined continuum, we cannot know them, but only perhaps conceive them intellectually with the help of mathematics. We can therefore better understand the two corollaries. If we stick to sensible reality or imagination, which depend directly on sensible data, we can always conceive that what is for us a sensible minimum is still divisible, at least conceptually or mathematically. However, beyond our sensitive capacities, this division must also stop, since the continuum, including the mathematical one, cannot be divided to infinity, as he showed above. This implies that this applies, to the sensible minimum, but also to the natural minimum in the extramental reality. There would therefore be 2 thresholds of divisibility: a physical divisibility, which would stop at the minima naturalia and sensibilia, and a mathematical divisibility, thanks to which it is possible to conceive of smaller indivisibles, which are point-like entities. If this is the position of Autrecourt, it is very close to that of Epicurus in the letter to Herodotus, and above all to Lucretius in the De Rerum Natura, who clearly distinguished between atoms and their minimal parts, in order to respond to Aristotle's arguments, relying precisely on an analogy with the minima sensibilia. So let me end this presentation with the last strategy, and I will be very short, that is of the puncta naturalia. What does it mean? Ramon Llull, who uses this expression, asks questions very similar to those of Nicholas of Fautricourt in his Ars Magna. But he doesn't really answer these questions. We find some details in his Nova Geometria, but it is still very brief, and he uses the distinction between natural point and mathematical point without really defining what is a natural point. He only says that it is something like a body with 3 dimensions. So it is a point with 3 dimensions, which seems, as I said at the beginning, like an oxymoron. So if we want to better understand this notion, we can turn to John Wycliffe 1 century later, who is much clearer, even though not totally clear. So this is what he says about what we may mean by natural point. Let me quote the text. Indeed, point may mean either a sensible minimum with 3 dimensions, which is the intrinsic term of a continuous and permanent quantity, or what terminates intrinsically a line, absolutely and without any part. Things of the first type are called natural points, lines, and surfaces by the philosophers, whereas the second type of things is called mathematical points, lines, and surfaces. So we find the distinction between the atoms of the philosophers and the atoms of the mathematicians. So on the one hand, small bodies, on the other, mathematical points. Just as we can conceive of the body as a 3-dimensional solid, we could also conceive of its depth, length, and even a point in it. The same would apply to the natural body, which would have the same structure. But it is not clear why the natural point should be considered a point if it is a body. His disciple, Robert Allington, at the turn of the 14th and the 15th century, goes further and assumes that the natural point is the primary subject of the mathematical point. Let me quote it, and I will end my presentation very soon, I promise. The natural point is a minimal and sensible 3-dimensional quantity, which, you might add, is long, wide, and deep, sensible to a minimal degree. On the other hand, the mathematical point is an indivisible, situated relatively to its position in a line, and which has a punctual substance as its first subject. According to others, the mathematical point is for a material substance the fact of being punctual. It is the natural philosopher or the geometer's responsibility to deal with the natural point, line, or surface, whereas it is proper to the mathematician to deal with the mathematical point, line, or surface. This is why the natural philosopher as such would not accept that the continuum is composed of non-quantified beings, whereas the mathematician would probably accept that. So as in Zimara's description in the 16th century, natural points are not real points, but minimal bodies. Either one posits a simple analogy between mathematical abstraction and physics, as Wycliffe seems to do, which leads us to think of the existence of an equivalent to the mathematical point in things, or one tries, as Allington does, to ground this analogy ontologically by making the natural point the subject of the mathematical point. But this does not work very well unless one makes the mathematical point the accident of this minimal body, however small it may be, and not its essential part. Since these authors defend realist positions in ontology, very much influenced by Platonism, it is not impossible that they consider natural points as instantiations of the idea of point, to which we have access only through mathematical abstraction. In any case, it is a way for them to keep the validity of the Neo-Pythagorean model, even in the description of natural bodies, but only at the level, at the level of matter, as in gross tests, for example, but of natural bodies in general. But it seems to me that if we want to keep Aristotle's hylomorphism and hylomorphic ontology, then the distinction between atomic bodies, minima, and points, as we find in the anonymous commentators of the De Anima, and also in haute recours, seems far much clearer and more coherent than the idea of puncta naturalia. So it remains for us to determine exactly what the positions of these different authors in the philosophy of mathematics are, and that will be for another presentation. But I hope that this presentation will help my colleagues who work on other authors and traditions. So thank you very much.